before we start the actual graphing, we're going to look at some graphs first and do a little bit of analysis, all right? Okay, so everybody okay with that? Yes? Yeah. All right, let's give this a shot. So, on the front of this graphing introduction, we have a rational function. There are 5 characteristics of rational functions, right? There's holes, vertical asymptotes, x-intercepts, y-intercept, and horizontal asymptotes, right? Those are your 5 characteristics. You can have numbers for each. You could have multiples for some of them. You could have none for any of them. It's possible to have none. All right, so let's go in order and see what you see in the graph. Do you see any holes?
Yes.
Where at? For the hole, do we look at the x value or the y value? For the hole, you look at the x value. What's the x value of that hole? 2. Yeah, it's right there. You see the open circle? This program is smart enough to make the holes. The graphing calculator one is not. So there's a hole at x equals 2. Do you see any vertical asymptotes?
Yes.
Yes, where at? Vertical asymptotes. You see any vertical asymptotes? -1. Who sees a vertical asymptote? -1. Anybody else? 4 people. That's it? 4 or 5? Okay. Just making sure we're all on the same page, right? Right here, because what's happening here? Your graph is going straight down and it's going straight up, right? And so there is a vertical asymptote at x equals -1. By the way, this graph is also smart enough to draw a dotted line for you. When we go to graph, we will be drawing in the dotted lines to help us out, okay? Do you see any x-intercepts?
Yes.
I saw a couple head shakes. Yes. Where it is across the x-axis? +1 right here. What do you think? +1? +1. Are there any more? Because there could be more, right? Are there more? No. All right. Y-intercepts. You see any y-intercepts? -1? Y equals -1. And by the way, there's only going to be one y-intercept. You can't have more than one. That's just a one or only. A horizontal asymptote. Do you see any horizontal asymptotes? That's at y equals +1. And that's what's happening at the end. So we don't care about the middle there. Over here, it's hugging the asymptote. It's curving out and almost running flat. And then over here, it curves as well, and it turns to a flat graph also. And it's turning at that y equals 1. That's where it starts to run flat at. All right. By the way, you can only have one horizontal asymptote as well. You can't have more than one. You want to try to write an equation for this graph? Let's give it a shot. It's not as bad as y'all think. We kind of get in our head, oh my goodness, this is going to be awful. It's not that bad. All right. If there is a hole at 2, what will we see in the equation? An x minus 2, right? You got to change that sign. And where will we see the x minus 2? Top and bottom, right? You can call them top and bottom, that's fine. Top and bottom, right? Because the hole appears in both the top and the bottom. So in the top and the bottom, both get x minus 2. Yeah, x minus 2. So that hole is now taken care of. It will be in the right spot. There is a vertical asymptote at -1. So what will the factor look like? That's x equals -1. X plus 1, and will that be located in the top or the bottom? In the bottom. So bottom and x plus 1. So check on the vertical asymptote. The x-intercept. X equals 1. What will the factor look like? X minus 1, and will be in the top or the bottom? That's the top, right? X-intercepts go in the top. In order to figure out your y-intercept and your horizontal asymptote, it has to be in the other form, right? So what we're going to do is we're going to go ahead and multiply and turn it into the other form. You've multiplied like this numerous times, yes? I wasn't trying to be funny. When you're done multiplying, check your multiplication with mine, see if they match. Yes? Good? Good. Awesome. All right, so then the question is the y-intercept at -1 already, or do I have to do something? It's already at -1. How do we know? It would be 2 over -2, and 2 over -2 is -1. So check, that's already in the right spot. Is the horizontal asymptote already at 1? Yes, because you would go to the coefficients, right? Because they have the same power squared. So it'd be 1 over 1, and 1 over 1 is 1. So most likely these will already be included after you've done the factors. Okay, so most likely they're already going to be included. We're going to see one where it's not, though. Yeah, let's do this next one. Number 2. All right, what do we have? We have holes, x-intercept. Nope, vertical asymptotes. I'm going to go with that next. X-intercepts, y-intercepts. I need a stamp that has all these things so I don't have to write them over again.
I'm sure it's the way.
All right, so we're looking for all 5 things in our graph. Do you see any holes?
No.
No holes? So we're good, no holes? Yeah. So the answer there would be no. Jacob, you got this? No holes? Yeah? Vertical asymptote.
Yes.
How many? There's 2. By the way, it could have 2, it could have 3, it could have 5. It's just depending on what the graph looks like, right? Where are they at? They're at x equals 1 and -2. Is everybody okay? 1 and -2, vertical asymptotes there. It's really nice when they draw in the dotted lines, isn't it? It's like you don't even really have to pay attention to the ends. You can just be like, oh, there's a dotted vertical line. That has to be a vertical asymptote, right? All right, what about x-intercepts?
No.
Does it cross the x-axis?
No.
James says no. What do you think?
I mean, the little curvy lines look like you're just going on forever and ever and ever.
Yeah, so what's happening over here is it approaches the x-axis. It's going and turning, right? And going forever and ever and ever. It's just getting closer and closer and closer, but it never actually gets there, right? On this side, it's turning, going towards the x-axis, and it gets closer and closer and closer, but never actually gets there. So at no point does the graph actually cross the x-axis. So x-intercepts there are none. This one's going to be interesting. No holes and no x-intercepts. That'll be unique. Let's talk y-intercept. 2. I'm cool with 2. Right there. I'll take 2. Crosses the y-axis at 2. And last but not least, horizontal asymptote. We're going with none. None. Does everybody think none for the horizontal? Horizontal asymptote, none. 1. Nash, what you think? 0. Anybody else think 0? Ethan's like, I put 0, but I was like, that's different than what somebody else said, so I'm just not going to say it. No. It is at 0, yes. And that's because of these ends, right? They're getting closer and closer, but they're not actually getting there. That's a horizontal asymptote. By the way, you can probably not see it, but there is a dotted line. You just can't see it because it's over top of the x-axis. And it's too hard to see, right? It is. And so sometimes your eyes deceive you a little bit. But check out the ends. If you don't see a dotted line, it doesn't mean necessarily that there's not one there. It means that it might be hidden on an axis or something. All right. Shall we write to the equation now?
Sure.
All right. No holes. So what does that mean? No holes. It's always easier when there's something, right? And then you just put in that something, you're good to go. It's like when there's nothing of it, we're like, what do we do? There's nothing.
It's just put a 1
But then you have the Y later on.
All right, hold on. You guys are way ahead of me. I'm talking about holes. Holes would be factors that are on the top and the bottom that match, right? So if there's none, what can we conclude? There's no matches. So what do we have to put in? Nothing, because there's literally no matches there for us to put in, right? Don't put an X. If you put an X, you're saying there's a match. Okay, so don't put even X's in. None is literally none. Don't do it. Don't put something in there, okay? Vertical asymptotes, where do those go? At the bottom, if it's +1, then it'll say X minus 1. If it's -2, then X plus 2. Both go in the bottom because both are vertical asymptotes. X-intercepts, where do those go? In the top, but there is none. So what do we put in the top? Don't put anything from the factors in the top, right? No factors in the top. So what does that mean is in the top? There's a number, right? Just a number. And the number doesn't even have an X in it. It can't have an X because if there's an X, then there would be an X-intercept or a hole, right? So it's literally just a number. When you know the number, do not tell me until I ask for it, okay? If you know the number, don't tell me. But there is just a number showing in the top. We don't know what number, but a number. All right. We need to make sure that this has the right y-intercept and the right horizontal asymptote, right? So in order to do that, I'm going to distribute the bottom. So x squared minus x minus 2 and some number in the top, yes? Right. All right, so now we have to, we can actually pick the number so we can get the y-intercept to match. So our y-intercept has to be at 2. So what number does this have to be so that it goes with the -2 to be a 2? Tell me the number now. What is it? -4. You see how that worked? So we didn't know the number at first, but the y-intercept told us what number had to go there. It had to be a -4. So when you divide these, you get 2. All right, horizontal asymptote. Is that at y equals 0? Do we have to do some adjustments here? Is it there or adjustments? It is there, right? Because the biggest power is in the bottom, and the power on the top is just a 0. So bigger degree in the bottom. So that would automatically be at 0 for a horizontal asymptote. So if we were to type this into our calculator, we would get a graph that looks like that. You just wouldn't see the dotted lines, and you wouldn't see the actual hole itself. All right, how are we feeling? What do you think about those? You don't like them? You like them out? Nope, done. All right, so what we did was we started with a graph, right? We picked out all the important pieces of information. We wrote it as a function in factored form, and then we went ahead and distributed, right? So when we go to graph in just a moment, we are doing this in reverse. We're going to start with this, right? Going to factor it, pick out the important pieces of information, and then throw it on a graph, all right? You see what we're doing? So we've done it this direction. We're going to reverse it. And to be honest, you've already done it up to here, haven't we? That's what you did on your quiz. You started here, factored, picked out the information. So now we're going to graph. So those last two are homework for you. Yeah, on this side, the last two are homework for you. So we are going to try some of these graphs now. All right, and this is not as simple as graphing a line. One second. Not as simple as graphing a quadratic, right? And so when we go to graph, there's going to be a lot of moving parts, and you're just going to have to pay attention to all the details. This is like detail graphing, okay? It's not as simple as this point goes here, and then the graph opens up or opens down, and you're good to go, all right? A little bit more complicated going on here. So as we're working through these, I don't expect you to feel amazing about every single question. You're going to struggle through them, and that's okay. We're going to talk about graphing today and more on Tuesday, all right? Yes. Yes, the Maria password. You go say? All right, so we're gonna go ahead and make our list of all our important things that we need to find. Same list as before, yes?
Let's be working for a week and a half now.
We've been making this list for a while. Well, we started by slowly adding to the list, right? We did one more thing, one more thing, one more thing. Now we got all 5. All right. So in order to find the holes, vertical asymptotes, x-intercepts, do I need to factor or am I good? We're good, right?
It's alright.
Good. Already done. That's because it's a line over a line. You have a line on the top and a line on the bottom. And so this is good. It doesn't make lines, but it is just 2 linear functions on the top and bottom. So is there a hole?
No.
No matches, right? Top and bottom, so no holes. Is there a vertical asymptote?
Yes.
Yes. Where is the vertical asymptote at?
+1.
+1. By the way, what does that look like on our graph of vertical asymptote at +1?
Dotted line going straight up.
Dotted vertical line going straight up and down. Go ahead and make it on your graph. We know what it looks like. Dotted vertical line going straight up and down. Yes.
Can I use colored pencils to color?
Yes, absolutely.
That's a smart idea.
If you want to make it a little bit darker with your pencil so you can see it, it's not a bad option as well. Make sure that your vertical asymptote goes all the way to the ends, right? Don't just be like putting it right in the middle. Make sure it goes the whole way. All right. Is everybody okay with what that looks like?
Yes.
Yes? We're good? All right. Up next, x-intercepts. Where are the x-intercepts?
-4.
You all agree with him? -4?
Yes.
Yes, -4. So how do I put an x-intercept on my paper? Just a dot, right? At -4 for x. Make sure you put it on the x and not the
Why?
y. That's a stupid mistake. It's an x-intercept, right? Did you say you must have did that?
No.
Oh. Oh, and you know, I did that in like 2 of my other classes. I put it at the wrong, it was negative, I put it at positive, and vice versa. All right, so just a dot there at -4. Okay, up next is the y-intercept. Where is the y-intercept at? Also -4? Yeah, also
Yes,
-4.
I guess it didn't really matter if you got on the wrong line.
Yes, this one's just a coincidence though, right? The only time they have to match is if it's 0 and 0, yes? Anything else, they don't have to match. But yeah, if you accidentally put it there, you would have been okay. All right, and last but not least, horizontal asymptote. Where? What did you say? 1. What do you think? 1?
I agree.
Yes, I agree with Ethan. And so what does a horizontal asymptote look like on your paper? Dotted line, but this time it's going horizontally through 1. The only thing we didn't talk about was the hole, but there is no hole, right? So that's kind of why I didn't bring it up. If you do have a hole, you put it on at the very end anyways, but you'll put all 4 of these on and just save the hole till the end, okay? But there's no hole for this one, so it'll be all right. All right. Are we prepared to make some curves?
Sure.
There is enough here to figure out what's going on with this rational function. So let's go ahead and see what happens. On this side of your vertical asymptote, over here, is the graph in the top or in the bottom? It's in the bottom. How do we know it's in the bottom? Because it has to hit those 2 points. Does that make sense? It's got to go through these 2 intercepts, so it has to be down here. Which means that it's going to start below that horizontal asymptote, and it's going to run, it's going to run along the horizontal asymptote, and then it's going to curve and hit the x and hit the y. And then from there, where does it have to go? Down along the vertical asymptote. So it's going to head that direction. And it's just going to be this nice smooth curve happening. That is not the only part of this graph though, okay? That's where these 2 points are, but there's always a graph on each side of your vertical asymptote, okay? So because we have the graph on this side of the vertical asymptote, we now need the graph on this side. Does that make sense? There's always graphs on each side of vertical asymptote. So on this side over here, it's either in the top or it's in the bottom. And this one's a little bit harder to tell, isn't it? Why is it harder? Because we don't have any points to go off of, do we? So take like 10 seconds and make up your mind if it goes in the top or the bottom. And we're going to vote. We're going to see what people say. There is enough information to technically decide. We'll see if you pick up on it. All right, that's about 10 seconds. All right, raise your hand if you think it goes in the bottom. What? Raise your hand if you think it goes in the middle. No, see, I got you all. If it goes in the top, that must be everybody else, right? All right, so do you have a good reason as to why you picked the top? Or you're like, I just heard Ethan say top really fast, and then I was like, okay, the top, and then we'll just go with the top. And you have thought of why the top? You want to share? Hannah, what you think? Exactly. So don't draw this, but what Hannah said was if it goes in the bottom and curves like this, it has to have another x-intercept. Do we have another x-intercept? No, because if we did, it would be on the list, wouldn't it? And so it cannot go in the bottom because it cannot cross the x-axis. Perfect. I love it. That was great. So because it can't cross the x-axis, it has to go in the top. And so it's going to have this nice little curve in the top. You don't have any points to go off of. You're just going to have it run along the vertical asymptote and then make it run along the horizontal asymptote.
Always better.
And then if we had a hole, which we don't, but if we did, we would put on our hole right now. Okay? How do you feel? What do you think? Was that super crazy or like, It was okay? It was okay. Just so you know, that was one of the easier ones. They will get harder, all right? All right. So don't be like, yeah, Miss Bird, I got this, I'm good. Because depending on if we have more of something or we have none of something or where the numbers are, will change what the graph looks like. All right, let's try number 6. Okay, we need holes. We need vertical asymptotes, x-intercepts, y-intercepts, and a horizontal asymptote. Are we need to do any factoring?
Yeah.
Just a tad factor, right? The denominator has an extra 3, so it'd be x plus
4.
4. 3 times 4 is 12. All right. Are there holes? Let's run through it real fast. Holes? No vertical asymptote.
Yes.
Where?
-4.
-4? All right, somebody besides Jim. X-intercept. You all know this. I know you do. 4. Y-intercept. Y-intercept? -1/3. It comes from this, right? And that does technically simplify to -1/3. And how about the horizontal asymptote? That one is +1/3 because those match, right? So +1/3. All right, is everybody, how do you feel about those values? All right, so what we're going to do is we're going to throw them on our grid. Vertical asymptote at -4, so dotted vertical line at -4. Technically, you don't have to draw the dotted vertical line as long as your graph goes the right direction. But if you don't draw it, it's going to make it really hard to graph. That's all I got to say. Even I draw it. I've been doing these graphs for years, and I still draw that vertical asymptote in there. Yeah, literally years. X-intercept at positive 4, so that's just a dot, right? They're at positive 4. Y-intercept is negative 1/3. As long as you're close to approximately where negative 1/3 would be, then you're fine, right? Approximately negative 1/3. So that would go down, I don't know, right in here, yes? Negative 1/3,
There, then
approximately. And last but not least, horizontal asymptote at positive 1/3. So that would be about right here. Yeah. There's a lot of stuff going on right in this spot, isn't there? That's okay. All right, and there's no holes. If there were, we would still put them on at the very end. We'll see a hole for our last problem for today. All right, shall we graph? You ready? Do you want to do the section that has the points or the section that doesn't first? The ones that have the points first? So you know that it has to be down here, right? So as it hits these 2 points, it's going to go horizontally this way. And then on this side, it has to go down, right, to run along the vertical asymptote. It can't go back up because if it goes back up, it would hit another x-intercept, and there isn't one. So just be careful. The x-intercepts or lack thereof tell you where you should be headed. All right, so that's this side of the graph. So this is done. There's nothing up here, okay, because it's down here. So that side is done. So we need something over here. Is it in the top or the bottom? The top. For what reason is it in the top? Because there's not another x-intercept. So it can't go in the bottom because it cannot cross the x-axis again. That is the 100% the only reason it goes in the top is because it cannot cross the x-axis again. And so you're just going to draw a nice little curve in there, running up and running out this way. And if you had a hole, you would put that in now. But we don't have a hole, do we? Nope, not yet. That one wasn't too bad. Very similar to the last one, right? Very similar because this was also a line over a line, right? It was just an X and an X on the top and the bottom. So the higher the powers are, the more complicated the graphs get. So, with that said, we're going to do number 8. Because number 8 is now instead of a line over a line, it's a square over a square, quadratic over a quadratic. So it is going to get a little bit more complicated. All right, this will be the last one we do today. So, holes, vertical asymptote, x-intercepts, y-intercept, and horizontal asymptote. All right, and before we can find those 5 things, we got to do some factoring, yes? How does the numerator factor? Technically take out a GCF. Is that smart to do it, to take out a GCF? Yeah, GCF of -2. Why do I want the negative and not just the 2? So the x squared will be positive, right? You don't want to leave that negative. So left over is x squared minus 1, and that should like alarm go off in your head, yes? Because I just said x squared minus 1. What do we know about that? It's a difference of squares. So this keeps going into x plus 1 and x minus 1. All right. And then the numerator's done, right? Denominator. That will factor 2 numbers that multiply to be 3 and add up to be -4. 3 and 1. I heard 3 and 1. And signs?
Negative.
Both negative, you're saying? Negative, yes? All right. Okay, we're almost there. We're just going to pull this information and then see what the graph looks like. Are there holes?
Yes.
+1. Vertical asymptote. 3. X-intercept. -1. I heard that in the back. everybody okay with those three? Okay, y-intercept. 2/3. That's gross. 2/3. And a horizontal asymptote. -2. All right. By the way, we have a hole now, right? In any case, you put the hole in at the very, and don't worry about the hole right now. Put everything else on there. So you put it on your graph. I'm going to put it on my graph, and then we'll check to see if we have the same thing. If you want to try the lines, go for it. Draw them in there if you think you can. All right, how are we with the placement of all the items so far? Good? All right. Have you already drawn the curves in there? Yes? Yeah? Okay. So the first curve you should have had looks like this, right? Yes? First curve. That one's the easiest because you have points to go through. Kind of tells you where you're going. The other curve, does it go on the top or the bottom over here? Why does it go on the bottom? Because of what? Doesn't have another x-intercept. And so it has to go like this. No more x-intercept, so it has to go on the bottom. And then you have to put the hole in. And so you're actually going to erase on your graph where x is equal to 1. So wherever your graph lives, where x is 1, erase it and put in a very large open circle. So it is obvious to everybody that you are addressing the fact that there is a hole right there in the graph. So your graph's going along, la 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 la, hole, and then it just picks up and keeps going, right? La 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 la. And no, like seriously, if it's that big, I'm okay, because then I can at least see it, right? The worst is when I'm like looking, I'm like, is that a hole? I don't know, I can't tell.